Well, in preference to what you're watching here, I'm in the process of taking the head holder rings off of this engine. We kind of left you hanging when we got done making the engine, and we're going to now try and finish that up today so that you can get some better idea for what the electronics that goes on the engine is actually about here. Now, and also how the mounting of everything takes place and why it takes place the way it does. We never mentioned too much about the internals that actually go into things, but this is one of the coils. This is the actual cylinder coil. That's the one that sets the speed, and this one here is the chamber coil. It's the one that sets up the action and makes the thing happen. So what we're going to do now is we're going to put these on, check their polarity, and then we're going to put the electronics on and put it together. And when we get done, you'll see what makes the engine actually tick. Now, all I got to do is figure out what I did with the dang nuts. Here we go. Put them over here so I can't find them. In order to complete the engine, now we actually have to go through and put all of the engine nuts, or all of the cylinder head nuts, in properly, which is not something we did last time. Okay, in the last video, all we did was put the engine together, and now what we're doing basically is we're going to show you what happens once you get an engine together. Now, we did bypass a video on how to seal up the engine, and I apologize for that because you'd have probably enjoyed it, but the fact of the matter is there's not much we can do about it now, since we're not about to tear down an engine that's already sealed. Now, the coils go on the cylinder. Now, if you're wondering, these engines are already purged. In other words, all of the oxygen that's in the engine has now been flushed out, and the engine is totally sealed. And so what we're going to do now, basically, is we're going to put the coils in. This coil is a cylinder coil, and it goes in like that. Now, there's a hole right here that wire right there has to come out. So the trick is how to put this in, grab that wire as it goes past. And that, of course, is always fun, because it's got to be just so when it comes underneath there. And if you don't get it, You get to pull it all back out and start again. And what's even more interesting is, while you're doing this, you also can't mess up anything else. So this is one of the parts of doing the engine that's kind of a pain in the ass. But there's one wire. So we got one. And I got to understand too that this coil only goes in that far. That means that the wires that you're trying to pull out are basically not going any further either. So, and you got to make sure you don't nick them while you're at it too. Kind of a pain, but we'll have to. We're going to make this slot bigger in the next group of engines so that we don't have this kind of trouble. Alright, now we've got the other wire. Pull it out. There we go. Now it's out. And hope we didn't nick it too bad. Doesn't look like it. But we'll end up putting a piece of shrink over it anyway, just to make sure it doesn't give us any other problem. Now the other one goes in, the cylinder coil goes in, and because this one goes in wire first, it's much easier. Except that, there we go. And now we had somebody ask us the other day on the internet, how come they couldn't see the coils? And the reason for that is that the first coil here goes across the transition chamber. The second coil here takes over goes over the rest of it. But it's also all inside this housing. Okay, now the next thing we do is we strip off a little bit of both wires. And the reason we're doing this is because the coils have to be set up so that they provide the right polarity to the cylinder. In other words, both coils have to be aimed basically the same direction. Now, in order to aim them, what we do is we take 12 volts from a battery and I guess we can do this. Okay. what we're going to do here is we're going to make this wire 12 volts and ground. And it's nothing spectacular, it's just a matter of hooking a jumper up to the ground side and hooking a jumper up to the hot side. And then we come back over here and we will now touch either side of the coil to get a polarity reading on the from the compass. And if you're wondering, I'm looking for a marking pen because I didn't mark these things up proper. But usually we've got this thing marked. The center two are our ground, and we know that, but they're not marked here now. And this is the cylinder controller, and it will be it is being changed get a better chair. That one's not all that good. We got one chair in the whole place that you sit in and it goes down, and of course I grabbed it. Now, the idea here, this board is in the process of being changed. As a matter of fact, next Tuesday, today being the 21st, so that'd be about the 23rd, 24th, we will have a new board to replace that board. And that board will actually have plug-ins. When that means that we'll be able to do all this and hook it into a plug-in and then plug it in there. And we're also going to redo how this is held here, and we're going to actually have it held by way of one of these screw bolts over here, a lot like the actuator controller is. But for now, I don't know whether you're going to be able to see this, but we'll take a shot at it. And okay, these two go together, so what we do is we put 12 volts on one and ground on the other one. Now, I don't know if you can see this or not, but what happens is when you put 12 volts across a coil, it creates its own energy. And if you can see this one here, you can see that if I hook it up this way, okay, north comes up right away and points that way. But if I turn this around, okay, then it goes the other way. It wants to repel the north. Okay? So basically we know that this is the proper polarity for this coil, because we can find out how it aims. Okay, so it wants to point north here. That means that the polarity is really north-south as we're hooked up this way. That means that this wire here wants to be our ground wire. And because it wants to be our ground wire, it will end up going right there. Okay. So now what we're going to do is we're going to whack it off a little bit. And we're going to get it nice and shiny. Strip it down a bit. And we're going to put it into the back center one. That's the ground. So we know that one there is ground on the back cylinder, or CC. Okay, and then this would be the front one here. So we'll cut it off and strip it down a bit. Now in production, this would be already set before it got here. This would be a red wire, the other one would be a black wire. And we would already know what they are. But these are engines that are more or less being done one at a time. So now, if what we just did is correct, okay, we should be able to put plus here, and where the, come here girl, there we go. We should be able to put plus here, ground here, and get her right, and she did just what she was supposed to do. Now, we come over, we're going to do the same thing to the next, to the first coil, okay, and then so we hook a little of that there, and okay, and that's south. So let's turn this around. Okay, that's north. Okay. So, now both of those coils are aimed in the right direction. And, okay, so I should have marked them. That's why I was looking for that black marking pen for. So I could mark one of them as black and one of them as red. But, in any case, I believe that's the way she's going to go. Yeah. So this one's black, and that one's, or this one's ground, that one's hot. So now we're going to do pretty much what we just did on the other side. Cut her down a little bit. Get rid of the long length. Strip it down a bit. And Stick her in the next hole here. As I said, in production, you'd already know what this was. You would not be having to do this. But it is important because if it's not in the right polarity, it won't work. And we do want it to work, don't we? You know, for those of you who are sitting there watching this video, okay, you all keep asking me the same question, and I think I need to answer it for you. You all keep saying, when can we see a running engine being posted? And I think you should know that we have manufacturers that make engines. We don't actually make engines. We have manufacturers that make engines, and that manufacturers, the manufacturers that we're working with, all want us to, together with them and others, okay, show an engine running at when we all have stuff to show. In other words, they want to be in that first party too. Okay, now that the coils are in, now what we do is we come back and we put on the retaining ring. Okay, and the retaining ring, where did I put it? Oh, over there. Now, when we first built this engine up, we built it up basically just so we could get it sealed and get it checked to make sure that it's sealed. But now we're building an engine that we are going to want, that we're going to run. And so in this case we have to put in more substantial bolts on the head. If you remember right, when we built the other engine, we just put in a fairly short bolt without lock washers, so that as the engine turned, it really wouldn't make a lot of difference. But now that we've got, gotta watch out where that goes here too. Anyway, but now that we've got an engine that we know is sealed and ready for fuel, what we really want to do now is get it ready to go, and in this case we want to put in bolts and lock washers so that we can be sure that as it runs it doesn't give us any trouble. Now, right this second I'm only putting in a couple of bolts here. We'll get back to putting in the rest of them here in a second. But there's something that you need to know about first, and that is that going here is a actuator controller. Okay, this actuator controller, okay, is the one that's going to drive the high voltage to the electrodes, and so we've got to make sure that we get it properly set as well. So this is one of those places where things are going to change in the future, because this particular mount is basically just kind of a test situation. Once the manufacturers start making engines, or start making their own version of the engine, they will probably come up with their own mountings and do away with ours. But we're trying to do a little bit of something about, helping them out. So We are now looking at making up a sheet steel mount that actually will go ahead and take care of both of these pieces. For training engines, there's no problem because these are easy to put in and easy to keep track of. Okay. Oh yeah, sure. They're also easy to put in backwards. Okay. Everybody laughed. John just put this damn thing in the other way around. Anyway, sorry about that. I wasn't thinking, I was sitting here thinking, damn, that fits good that way. And maybe we should have done it that way. But that's for another day to look at. For today, we've got to just go ahead and take this out of here and turn it over. It goes the other way around. And my apologies, folks. I just kind of. But anyway, it's Saturday and I'm goofing off, and quite honestly, I've got to have both these engines running tomorrow, so I've got to get. I've actually got 3 engines sitting here right now, and I will be putting fuel in all 3 of them to bring up tomorrow to run. But we can't get into that particular part of the program at this point. As I said, all of the people that we're working with to make engines don't want. Oh, that's fine. If you're wondering, okay, this is down here, and the reason this is down here is because we have this viewport here, and we want to be able to see what's going on in the engine, and that kind of thing. So, anyway, but this will get everything out, kind of. Now, we actually use different transistors in different areas, and this design, this electronics design, has been done in a way that we can use different kinds. Okay, for instance, you'll notice these are TO220. They stand up. They get cooled by this heat sink that's on them. The other one we use is like this, and this is what's known as a D-type, and you'll notice that the board itself will take either one. And the reason for that is because depending on what our source is, if they start to run short, we can go back and forth. And also, all of the electronics boards are being made for us by other companies. So they're coming in from some supplier, and we can tell the supplier you can use either this chip or that one, or we have a list of about 8 different transistors that will actually function just fine in here. And we get around that, and we're able to do that because on the master controller we have 4 amp drivers, and these 4 amp drivers will do any one of the transistors that we use in the engine with no problem at all. So anyway, now we're putting bolts in. That's fun. But you saw that this particular ring is just a ring. I mean, it's this ring actually has 2 very specific and very large functions. Okay, the ring itself, when you put it in, when you put it in, it's meant to hold the cylinder and keep it from being able to wobble. Okay, you'll also notice that there's a brake here. I mean, you can actually put something in here. And everyone keeps asking me, why don't you put a gasket in there? Well, the fact of the matter is that the cylinder in here is sealed at the bottom of this carrier here. The head is sealed to the cylinder. So there's no gas that can leak out through any hole that happens to be here. So there's no problem for a gas leak, and there's no problem for getting any of it or losing any gas or having anything happen. So the whole idea is that we basically use this head as a spring mount. In other words, we bring it down till it's about tight on all of the different bolts. Okay? And we make sure and do that in a way that is radial in the way you do it. In other words, kind of tensioning the ones opposite each other. Okay, until you get them all kind of down. Now, later on there will be a torque spec for this, but for right now it's just snug. Okay, and that's all it has to be, because this particular part does not carry any pressure. So all you have to do is make that snug so it's got your lock washer down and away you go. Now, okay, so that's one cylinder up to that point. Now, the next thing you got is every electrode requires a high voltage. All four of these electrodes have to have a high voltage on them. So these are 110,000 volt per each high voltage coils, 12 volt coils. Now, we also put them on in a very specific way. One goes here. Two goes here. 3 goes here. And 4 goes here. Now, you may find that a little, why do you do that? Well, we do that because, oh, and then this plugs in here, like that. Now, each of these, we do that because we have a specific sequence that we use in firing in the electrodes so that we get the proper voltage on the right place inside the head in order to make the thing happen, in order to make the transition happen. Okay? And so we have a very specific firing pattern that we use here. And that's what's going on with all this stuff here. Okay, so that takes care of that side. Now, we got to do pretty much the same thing on this side. What we do now is we're going to basically run the same program. Typically, and now that I've done this a couple of times, I don't know why I didn't think about it sooner, but I will sit down with the rest of the coils and make sure that I get a black mark on whichever side is the right side to make it go ground. Now on this side, we got exactly the same situation going to happen that we had on the other side. Okay, we're gonna have two wires we're gonna have to pick up after we put this coil in. Come on, girl. What's your problem? Oh, shoot, do I have a screw? The mounting screw for the cylinder controller is plastic, and evidently when the guys put this one together, they put it, they didn't cut it off shorter, so it goes clear through the cylinder, or clear through the cylinder carrier's shell, and it's coming out the other side, and it's stopping me from going in. Now you can see it goes in just fine, and with any luck we won't hit the other one. Ah, it didn't. Okay, good. Except that one of the wires didn't want to go in right. So, fun stuff. Come here. There we go. And sometimes they just happen to be right where you want them to be. And when that happens, everybody is happy. Okay, so that one gets taken care of. That one. And we'll reposition it a little bit to make sure that it's square in the hole. Okay, like I said, it's not black magic. It's just something you got to do. So, and it's a learning curve. We've only made about 12, 14 engines. It seems like finally we've gotten down to something that we're making the same every time, which makes it pretty nice, because quite honestly, making a different engine every time you turn around is a pain in the ass. Anyway, but I'm sure I don't have to tell anybody that's ever done anything like this that. Alright, now this time we'll get a little more efficient here. Start with it about the right length. And if you're wondering, that's our radio frequency input, or used to be. Now, of course, the radio frequency amplifier is actually built right here, and it would normally be wired up to the radio frequency jack, which is right here. Okay, that's where it goes in. But when we're playing, just plain testing with engines, we use it to provide the radio frequency power we need to make the engine function, or to make the engine go. And it also allows us to try different frequencies and see what happens, and we can actually check the output power of the engine as we change it, and even more, we get a chance to monitor the input current that the engine requires to do its job. In other words, the current that the engine takes is basically the input power to the engine. Now, you can say that the wattage is actually the true measure of that, because it's voltage and current both. For instance, the bigger coil here can have up to 53 volts on it, and the smaller coil here can actually have as much as 80, and that kind of depends on how good the mix is, and how good the ionization characteristics of what's going on in the chamber also is. So you end up with a situation where you've got to know pretty much what the hell is going on in order for it to and you can actually, you know, kind of have a look at that as you're running with just a simple voltometer. But it allows us to see. It allows us to vary that radio frequency up to 135 megahertz and see what's going on. So, okay. Come here, girl. Alright, sit right there. Okay, so this one's ground, and it will go here, and that one will go here. Actually, I think probably downstream we will change the DC to DC power box, which is that box back there. That box back there gives us voltages, the voltages that we need based on between 9 and 48 volts DC in. And what it does is it allows us to work with many different vehicle batteries. Some places have different different voltages than we have here in the U.S. For instance, trucks in Russia, for instance, actually run at 48 volts in some cases. Did I? Okay. I guess I'm just not making a connection here. Come on, Gert. And if you're wondering, Gert, I say that because when I was a kid growing up, my grandmother gave me and my brother Bob each a goose to watch over us. And my goose's name was Gertrude. And it was supposed to be a good deal for me because it was supposed to keep me from having to watch him all the time Unfortunately, his goose allowed him to walk right out in the highway and almost get hit by a Greyhound bus. I know, you're going to say, well, gee, why don't you just let him get hit? I suppose if I'd have known then what I know now. Anyway, no, he's my brother regardless. This one doesn't seem to be wanting to do his thing proper. Come on. Okay, there you go. So, now this one is ground. And it goes into the electronics controller here. Now this particular unit that we're working with here, which I call the cylinder controller, is taking its voltages, its primary speed voltage comes from the red and black pair, and the cylinder the transition voltage it gets from this pair here, and they're being developed over there as DC current. But once the reaction, or once the transition has happened, has started, we revert this coil over to that coil so that we've got a continuous coil. Those of you that have been around any of my seminars will know what the hell we're talking about when I say that, but we have voltages that we use to squeeze the gas in order to make it work properly. Now, okay, we're ready to put that head back on and hook up this controller. So, this is one of those more or less boring things, but oh well, gotta be done, right? Anyhow, the way the engine works is on a voltage cycle, a voltage and current cycle, where the coil controls the virtual cylinder and also the amount of pressure. Gas in general does not like to or can be contained by, as most of the fusion scientists you'll know will tell you, that gases are contained by electromagnetic fields. And basically that's what these coils do. It's not quite that simple, but it's really not rocket science either. It's something we've known for some time. It's a little bit like plasma. We've known something about plasma for a while, but we've just never really crossed the boundaries that this engine has crossed. This engine uses a little bit of fusion science, a little bit of plasma science, a little bit of fission science, and quite honestly, it was, when it started, just a lab experiment that failed. But I'm kind of glad that it failed quite the way it did, because it kind of proved to all of us that do work with this kind of stuff. Now understand, okay, I had physics in the 60s. I had physics a very long time ago. And most of what we were taught then have been kind of misproven or disproven nowadays. So it's not something that you're going to, I mean, the basic problem that we have in science, period, today, is that all of the generalization is gone. And by the way, okay, if you're wondering, this is the same thing is true of engineering. I mean, we have great software engineers who have no clue what the hardware that they're programming does. We have great systems designers who know all about making or hooking up two electronic components and how to make them tick, but couldn't program their way out of a paper bag. And to me, this is a huge mistake. And we have the same problem in physics. In physics, we have people who understand quite well anything that's happening with the fusion of two atoms. But we don't have, and we got people who understand how to make plasma with a nuclear or with gases. And we got people who know how to do fission. Okay? The problem is, and this is something I found out when I first discovered how this engine worked, and went to some of my friends to get it validated. Okay? We don't seem to have people who understand more or anything outside of their field. In other words, outside of the people you see on TV who really do seem to know what the hell they're doing, most of the scientists are busy with their projects, and they haven't a clue about anything else in the world. Now, to me, this is a critical element, because if you don't understand what's going on in totality, then you're going to have a hard time making anything new happen. Because if it gets outside of what you know, you're not going to understand it. And quite honestly, this engine is a prime example of that. Now there isn't anything about how this engine works that modern physics doesn't know. Not a single thing. There's no black energy, there's no dark force, there's no magic formula for the fuel, none of that. It's all plain old-fashioned, everyday, run-of-the-mill, standard physics. Some of it is a little bit, let's face it, we use a fusion event to create to make the plasma grow. Okay? PAP used a fusion event to make the plasma grow. Okay? No one understood what he was doing. Even Feynman, okay, which in my view was the very first mistake that was made on the PAP engine, was made by Feynman, because had he used a proper scientific approach, he would have studied the engine and not tried to sabotage it. But he didn't, and so it never got the kind of publicity or kind of study that it should have. Well, one thing I should tell you about the bolts on this ring, even if you don't get it dead on, it'll be okay. Because the head and the ring have got a angled environment where they come together. So basically it can rock on there and it'll still get it where it has to be. Okay, so that's now on there, and what we're going to do now is we're going to put on the pack here for the high voltage coils. And these are just pop-ons. We've got one. The electrodes in here are all standard spark plugs that have been cut. You know, the end has been cut off of them. Okay, so that we can use them as electrodes, not spark plugs. And the reason for that is because I couldn't come up with a simpler way to make electrodes than use plain old everyday run-of-the-mill spark plugs. You know, when the guys that make the coils decide that they're going to make, you know, they're going to be down in a couple months, they're actually going to look at making this whole piece a single piece that goes in and turns. Okay, so now that takes care of the cylinders. The cylinder controller is in, the actuator driver is in. Okay, the only thing we got to do now is put in the master controller. Oh, anyway, so besides the radio, over here you got a scope with another scope. Those are both the computer is actually a programming thing that we use to program this test unit. And I'm sure anybody that's been here has seen this test unit work. It just sits here and creates a spark, so we can, or an arc, or set up the arc as it goes around, so you can see if the thing is working. And of course, these all go through that before they get used, so we can verify that they are live, they are active, and they are complete. Now, the engine controller, okay, is this little girl here. Now, the engine controller actually has 3 computers on it. There's one there, which takes care of this. There's one here that takes care of those. And there's one here that takes care of those and orchestrates the whole thing. All 3 of these computers are hooked together right here by what we call a CAN bus. Now, I always call it car area network bus because typically CAN buses are used in either cars or some other kind of vehicle. The reason for the CAN bus is so that each of these processors can talk with the other processor about what it's doing, why it's doing it, what the speed of the engine is, etc. And of course the reason for that is that the pattern that we use on these high voltage coils changes as the speed of the engine changes. The frequency that this radio frequency device produces, okay, changes based on the speed of the engine. The voltages that are being provided over here by the DC unit also change by the speed of the engine. All of these things must work in exact unison, and if they don't, the engine will not run properly. Okay, so for mounting, we just kind of made this simple, stupid, and we just kind of hang it on the bolt here. And if it doesn't want to hang on the bolt, which this one doesn't seem to want to do, if you're wondering, the engine's sealed, and these bolts don't have anything to do with the seal. They really have to do with mounting. So what we'll do is we'll take this girl and we'll put it right down here on this, and we'll get it down here and get it hooked up. gotta love these new modern things. I mean, damn, when I was a kid we used to bust our knuckles every time we turned around playing around with something. Okay, so now we know I got the master controller set. Okay. Now, the next problem we've got is hooking up everybody to everybody. You notice that everything here has a ribbon cable running to it. Okay, these ribbon cables actually go in to this. They're keyed. They go in there and they lock. Bang, like that. Okay, that means that it's not going to, under any form of vibration, come apart. And it's also a nice, easy way to get voltage and signals and everything transferred from one place to another. And that one doesn't happen to have a cover like that one does, but okay. Alright, so what we do then is we go through and we plug all this stuff here in. Come on, girl. There you go. Sometimes you got to make sure and get them so that they do their thing proper. But anyhow, that makes everything from that standpoint pretty easy. Now, the sensor, these guys here are set up to come out for testing and that kind of thing, are set up to come out here to a light emitting diode, which actually looks down here. Okay, that light emitting diode is set to what this computer thinks is top dead center. So it will flash every time this comes under it if it's correct. And then there's another diode, light emitting diode, that normally goes in there. Yeah. This is a new controller. In the older controller, okay, you can see that we actually had the diodes mounted to the board. But in the new boards, we have this taken back so that we can just plug them in and hook them up to a little travesty, check them from that standpoint. Okay, the other thing we did with the new controller was, you notice we now have our programming for each one of the 3 processors is separate, whereas here it was done by way of this switch. Okay, so we're coming up to pretty fast now on how all that works too. So anyway, and if you're wondering, yes, that controller works just as good as this controller, and as a matter of fact, it works just as good as the one that was replaced. And the whole thing replaces basically what was at one time one computer here, one computer here, and another computer here. So what we've done is we've tried to get this all broken down. Now, normally this would be short, but for testing we leave them long so we can just plug them in. Okay, but the normal process would be to shorten that up. And if you're wondering, these just go in and screw down just like these did, and anything else that's here. Now the only thing left to do is to provide power to things. And I'll give you some idea how the wires go in. You can see here, here's a 2-way plug, and this one is going in here like that. This one is going to go into here, and this one, which seems to have decided to come apart, is going to go over here. So what we'll do is we'll get this one here ready to go. Normally, we have the ground side of all of these things marked, but for what we're doing here, we're basically working with pretty standard stuff. So we didn't spend the time to go through and mark them properly, which we should have. But in any case, this one now goes here. Now, I've had somebody tell me, well, gee, you're not giving it much in the way of 12 volts. Well, the fact of the matter is that we don't have to give it much in the way of 12 volts. These coils are quite efficient, and they do what they got to do. Now, you'll notice that there are two openings here. This opening here takes a plug, a three-way plug, and that three-way plug, I don't know if I got one handy. I got two, yeah, three-way, okay. But this three-way plug can go ground and start. It would go down to that box or to the starter, and that would be able, that's so that you could do a remote start. And the other side over here is what goes to the valve that turns on and off the gas to the refueler. Now, gas to the refueler is basically handled by a little valve like this with like a CO2 cartridge attached to it. And it would go here and hook into here. And basically we take the valve out of that. And this would then be driven from a wire from there. But we don't have that. Now, this one over here is a CAN bus. High, low, and ground. And this one is the one that would go out to whatever you're using or whatever you're hooked up to that you may want to be controlling the engine from. For instance, we can hook this into a little Bluetooth receiver and use an Android pad to actually control the speed of the engine. Okay, so that's basically just an I/O. These are not used in the kind of testing that we will be doing next. Okay? So, now you've got a complete engine. The next step in this engine would be to fuel it. And I should go get something here. When it comes to fueling the engine, there's a very specific pattern that goes through. But I thought just for the heck of it, you might enjoy seeing this. This is the first controller that we used that was totally successful. And believe it or not, this controller still works just fine. In other words, all of what you see here is now done here Okay, what we've done is the parts that would fail or can fail in short time are now off board. The parts that will probably last forever, like the microcomputers and stuff, are now on this single board with the drive. And we learned that because in this case the radio frequency amplifier here was actually relay driven to each cylinder. Well, we've now found out that we can do that by, we actually put the radio frequency amplifier in both cylinders. So if, for instance, one radio frequency amplifier dies, but the other one doesn't, we can actually change this board while the engine is running. Okay, the engine would be down to one cylinder at the time, but we could change that board, okay, and plug in another one and have the engine back up in a heartbeat. The same thing's true of these. Okay, these, and someone asked me, well, why don't you have a lot of cooling on that? Well, quite honestly, if I was going to cool something, it would be this one. And the new board that we have coming for this, to replace this, actually is a little bit wider and actually has got these where they can be cooled, or where the D-type, the lay-down types can be used. And the reason for the lay-down types is that if we use the lay-down types on the back side of the board, the aluminum cylinder could now be used as a heatsink. These actually get warmer than these. The actual amount of time, the amount of time that these transistors are actually being used is less than 2 milliseconds out of every stroke. So they don't build up any energy. In other words, I could turn on the test unit over here and leave it run for 15 minutes. Is it hot? Yes. Did it fail? No. But if you look, you'll find that here you'll find exactly the same as what you have here, except that here it's all done in one board. Now, the problem with this board really was they quit making this chip. That processor is no longer in existence. So we had to change from the processor in a moment. And when I did that, I went ahead and redesigned the system so it's more modular and easier to fix in the field. You know, the idea is that if something happens, if one of these transistors goes bad, you can plug another board in there, etc. So we have spent a good deal of time and design time in getting the engine to its simplest form. One of the things that was not said in the other assembly video was that we actually have, or will have within 2 months, injection molded pistons made out of a high temperature thermoplastic that has the same basic slipperiness as the rings that we use in here, the Teflon rings. And that will replace the metal piston because we don't have the heat. Okay? Now, when it comes to fueling the engine, which is what we're going to do next, okay, we always did this by hand and we always did it the hard way, in my view. So, because we have manufacturers that are going to be making hundreds, if not thousands of engines a day, and some of them already have gotten to the point where they're doing it, a couple engines a day, I decided that we needed to come up with some kind of an automatic fueler. So what I did was I designed a computerized fuel mixer and engine filler. In other words, you push this button and it purges the block. You push this button, it mixes the gas. And we have 16 different mixtures available. And you push this button and it fills the engine. And then you undo the octopus that sits here, one there, one there. And the engine is now ready to go over, plug into whatever you're going to test it with, and test it. So it's a lot simpler, and we use the same basic valve from this as we are, or may use for there, or we may actually find something smaller for there. But this valve actually sits one per gas chamber, or one per gas cylinder, and it creates the gas into a manifold and then swaps the manifold into the engine. So now we have this down to a simple tool. When this is finished in a box, it'll be all about yay big, about that much wider, okay, and it will be self-contained. Push the button, everything happens. Yeah, well, plug it in the wall. But anyway, I'm just trying to explain to you how far we have gotten ahead of the manufacturing and maintenance side of creating one of these engines in mass production. Okay? So that's as far as we're going today. I'd like to have you here for when we bring this engine up and make it go purr. And it does go purr. Anyone who thinks that this is a paint shaker is kind of really off in the weirdies someplace, but yeah, we all know where those people are anyway. Anyway, so that's all we have for this session. As soon as we have manufacturers and products, we will be going public, but between now and then, we have no reason to do that, because we have a technology that we know works, and that's all the hell we have to worry about. So, you all have a good day and have a good life. Enjoy it, right? Okay, bye-bye.